No, next Friday, the 23rd. Morning. Oh. Oh, so slow. Okay, okay. So it turns out that there maybe was an area problem on the homework. Whoops. If you do the read it, watch it, I'm sure you could do it because it's just a formula. You just plug in the numbers into the formula and then type it into a calculator. But also the formulas in the guided notes. I could actually probably pull them up sometime this hour if you just want a picture of it. It's not too bad. For class today, we're going to start law of cosine 6.2. That's going to take today and tomorrow. And then it'll be due on Monday. You want to launch this meeting? That be good? Hey, there we go. You just have to grade it a little bit to get it to work. For bell work, we got two problems. One, review from yesterday. And two, number 60 on the ACT. Supposedly the most missed question on that test on average. I'll give you 4 minutes. Try it on your own, and then we'll go over it. Okay. So the first one here is a review from yesterday. Does anyone know how do we get started? Yeah, first thing you need to do is find angle B using your law of sines. So what is angle B? Well, we can do sine of B over B equals sine of A over A, which gets us the sine of B. If you plug in the sine of B over 5 equals the sine of 31 degrees over 12. And then to solve that for angle B is 2 steps. You need to get rid of the divide by 5, and then you need to get rid of the sine. So you should end up with, to get rid of the divide by 5, we'll times by 5. And then to get rid of the sine, you'll take the sine inverse of that. If you type that into the old calculator with a, make sure it's in degree mode, and you should get 12.392 degrees. Okay, but now here's the tricky part. That's not the only solution for B, right? There could be another possible solution for B. If we subtract this from 180, that could give us another possible solution. If you did that, you'd get 167.608 degrees. But is that a viable solution for your angle? Got some yeses, got some nos. Compare that with angle A is the key test. A plus B has to be less than 180 in order for it to be work, because right, the three angles have to add up to 180. So if two are past 180, there's nothing left for C to be, right? And if you add 31 to this, you'll see you get like 198. And that's bigger than 180. So that couldn't really make a triangle because there's no possible angle that C could be, since we don't, allow negative angles yet. So it turns out that there's only one possible triangle that has these dimensions. And thus, we basically can ignore this over here. I just moved my bottom toolbar. Get out of here, bottom toolbar. I don't want you there. There you go. Go back. Good. So then we need to find C and side C. And those are, I feel like, pretty quick. But I don't know. Let's just go with a random person for this. Not 3d6. 4. 1, 2, 3, 4. Brianna, how do I find angle C? Yeah, add the two other angles and minus that from 180. So 180 minus 31 minus 12.392 gets us 136.608 degrees. It's a pretty big angle. All right, we'll go. I'm gonna roll one more time, just see who's going next, right or left. That's even, so that's gonna be right. Lucas, how do we find, now that I know angle C, how do I find side C?
C, the little c, over the sign.
That's right. Yep. Yep. Just use the law of sines with sine C. And we're going to set that equal to a sine A. So I don't know. I feel like we've done this 1,000 times in the last few days, but that's sine of 136.608 degrees equals 12 over the sine of 31 degrees, which means C is sine of 136.608 degrees times 12 over the sine of 31. Calculator. And we get 16.006. That should be squiggly, 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 squiggly. And if you check your answers, it should make sense. Angle C is the biggest, side C is the biggest. That works. Angle A is in the middle, side A is in the middle. Angle B is the smallest, side B is the smallest. So everything is matching perfectly. You know you did it correctly. Pat yourself on the back and say, good job, me. I knew I could do calculus. Yay? Any questions? Anybody need more time to write? Because I think we'll have to clear this to make room for that number, 60. Nice thing is the law of cosines, I feel like, is even easier. Law of cosines, as long as you, is more algorithmic, as long as you follow the steps. There's not like ambiguous cases where you have to try, different things and do like a test. All right, number 60. The equation y equals 2x squared minus 18 over x squared minus 5x, this rational equation here, has 2 vertical asymptotes and 1 horizontal asymptote. What is the horizontal asymptote? Does anyone remember the test? Do you remember? What do you do? That's right. You check the leading exponents. If it's bigger on top, then it would be none. Bottom, yeah, there. Bigger on top, none is the acronym we used. If it's bigger on bottom, then it's 0, Bobo. And if the exponents are the same, do you remember what you do? Divide your coefficients. I think I wrote these backwards. It's supposed to be Bobo bot in HTC, not bot and Bobo HTC. That would be ridiculous, right? That acronym doesn't work. If the exponents are the same, in this case they are, they're both 2, then you divide your coefficients. 2 divided by 1 is 2. So, well, they don't make you have to choose between x equals 2 and y equals 2. But you know the answer if it's a horizontal line, right, going through the y-axis at 2, such that y is always 2 because it's horizontal, then it is y equals 2 and not x equals 2. And again, if the exponent on top was bigger, like if this was a third power, right, then there would be none because the top will increase faster than the bottom. So there's no limiter to that. And if it was bigger on bottom, if this x squared in the denominator was really a third power, then it'll accelerate faster than the numerator, right? And so as you go to infinity, the denominator becomes much larger, which means anything divided by a really large number is close to 0. That makes sense. If I have, 1,000 pizzas to split between 1 billion people, basically nobody's getting pizzas. They're getting like really tiny, chopped up fractions of a pizza.
Which is sad.
It is sad. but also maybe somebody else in that billion people could have helped brought pizza. I brought 1,000, right? Okay, it says there's 2 vertical asymptotes. For fun, I think it'd be fun to find out what those are.
No,
Don't you think that so?
no, yeah.
How do we determine when there's a vertical asymptote?
We're not good on this. Oh, we already know this. Well, we don't need to determine it. You just need to find out what it is. Equal. Well, we know it's there. Set something equal to 0.
What do you set equal to 0? The top or the bottom? The bottom, the denominator.
Yeah, sure.
And that's actually really easy to solve, right? That's, you just solve that by factoring. The 2 zeros would be 0 and 5. So vertical asymptotes happen when the denominator is 0. Horizontal asymptotes, you have to do this test of the powers, whether it's bigger on top, bottom, or if the exponents are the same. Okay, but let's say it's question number 60. You get there with, I don't know, 2 minutes left, and you think, I do not remember the rules. You could just graph it, right? Graph it and look where the horizontal asymptote or the vertical asymptotes are. And if you look, you'll see that there's this horizontal line, and you only have 2 choices. Is it 0 or 2, right? It's a horizontal line, so it has to be y equals. There's only 2 choices, 0 or 2. And just looking at the graph, you could tell the difference between those 2. You know what I mean? Do you know what I mean? I mean, do you really though? Let's see. Seeing is believing. Right, you graph that and you look at this. Nope, did I goof? Did I goof? Is it possible? Not 55x. All right, if you look here, you'll see that as you go to infinity, right, that's your asymptotes. If you look, does that look like it's going to 0 or 2? Does this one look like it's going to 0 or 2? Right, it can't be going to, it's already past 0, right? You know it's above the x-axis. Can't be 0. If you draw the line, you see. If you zoom out, it looks even better when you do it. Yay. All right. Law of, any questions about that?
How you doing?
Huh? I'm doing good. I'm doing really good because we're about to do the law of cosines. And the law of cosines is fun. I'm a big fan of the old law of cosines. All right, there are 6 formulas here, but you will notice all 6 of them are equivalent, really. Okay. One of them is solved for a side, one of them is solved for an angle, and then they just switch up the letters. You do not need to write all that down. To be honest, you could be fine with just that. If you want to write down this, that's fine too. If you want to write down the whole thing, I don't. It's on your trick cheat sheet, I think. Did I give you all the versions? I don't know if they give you the alternate versions on the trick cheat sheet. Let me look. No, they don't give you the alternate. So if you want to do one of the alternates and add that to your trick cheat sheet, that could be a smart thing to do. Right? Like here's your trick cheat sheet. Here's the law of cosines on yours. They don't have the alternate forms. So if you want to put one of these alternate forms right here, that might be smart. Okay, but let me move this tab over. Okay. All right, so if you're reading this, how this works is you will use this whenever you're given 3 sides or 2 sides in the included angle. Yesterday, we were doing 2 sides in the not included angle, right? But if you have the angle between the 2 sides, you actually can't use law of sines to start with. You'll see that. Like if you try to use law of sines, it won't work. Then go use law of cosines. It's impossible really to mess that up because if you try law of sines, you'll have two unknowns in your equation and you won't be able to do it. And then you go, oh yeah, wait, I'm supposed to use law of cosines. Each of these relates a pair of sides with its angle, a side with its opposite angle with this function of the other two sides. So like here, we use the pair of side A and angle A, and then the stuff in the middle then becomes the other two sides, b squared plus c squared minus 2bc times cosine of angle. All the rest of these are just flipping letters around. That's why I say you really don't need to write it. This one uses angle B and side B, and thus in the middle here, wherever you have a B, you put A instead. This does side C and angle C, so wherever you see a C here, right, you can put A instead. It relates a side to its angle, and then it's got this like Pythagorean theorem looking thing, minus 2ab. And then again, over here, these are just solved for cosine of A. So we minus b squared and a squared to the other side, and then we divide by negative 2bc. And they went ahead and divided by the negative, which is why a becomes negative and the other two become positive. But you can get this alternative form from the standard form. You just solve for the cosine of A by subtracting and then dividing. But it can help to already have it solved for you, right? And again, you will use this when you're given three sides or two sides with the angle in between. That's when you use the law of cosines. Yay? Do we need anybody or anybody need more time to write? Okay, let's do an example. For example, for this triangle, I'm given three sides and I need to find its angles. If we want to find angles, we will want to use the alternative form because we're going to solve this for the angle. And here's the most important thing you will write down today. This is what will either make sure you do law of cosines just fine or will get you in trouble. Always solve for the largest angle first. If you do not solve for the largest angle first, you will get into an ambiguous case where you don't know whether or not your angle is acute or obtuse. And you will create different versions of the triangle that you won't realize doesn't work until you've already solved for all the other angles. That's a lot of extra work to cancel out at the end and realize only one of them is an option. So if you always solve for the largest angle first, you will not run into that problem. You will only have one case, and there should only be one case. This triangle has three sides. You know from geometry that side, side, side is enough to ensure triangle congruence. So there is only one possible triangle, one size and shape that could have these three sides. There should not be an ambiguous case. All right, so let's go ahead and do it. Which one would be the longest angle for this triangle? Angle A, B, or C? B. B is the largest side, so B is going to be the largest angle. So we're going to do cosine of B is equal to A squared plus C squared minus B squared over 2AC. All right, I'm going to solve this a little bit longer way than you'll do on the homework, just to demonstrate to you why this statement is so important. If we plug in our values for this form, we get the cosine of B is equal to 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. Type that into the calculator, bleep, blop, bloop. You normally will skip this step, but I'm going to do it to show you something. Type that into the calculator, bleep, blop, bloop, and you get about negative 0.451. That negative is important. What that negative is telling you is whether or not your angle is acute or obtuse. Where is cosine negative? In what quadrants? Well, cosine's your x value on the unit circle, right? So where is x negative? Which quadrants? The left ones, 2 and 3. Now, your calculator will only ever give you answers in the first and second quadrants, which actually is very useful for us. Because this is negative, we know our angle is going to be in the second quadrant. So we know it's going to look something like this. So we know it's obtuse. There's only one possibility. It is the obtuse angle. If you solve for another angle first, you'll get 2 possibilities, and then you won't know if it's obtuse or acute. I say that. You should know that it can't be obtuse or acute. I mean, you should know, because there can only be one obtuse angle, right? In a triangle, there can only be one angle that's above 90 degrees. If 2 angles were above 90 degrees, it would add up to more than 180, right? So if there is an obtuse angle, it will have to be with the largest side, right? So when we solve for the largest side first, using cosine, we force our calculator to give us the only angle it could be, because this ratio turns out to be negative, and that's the angle in quadrant 2. So long story short, again, you always need to solve for the largest angle first, because that'll tell you whether or not your largest angle is obtuse or acute right off the bat, based on whether or not this is positive or negative. Ultimately, though, for your homework, really, your first step will be this, and then your second step will be to, just to take the cosine inverse of that big thing. And you don't actually need to know if it's positive or negative. You can just type that whole mess into the calculator with the cosine inverse, and you can trust that it is going to give you the actual angle for that one. There will be no ambiguous case. What your calculator tells you is correct. And if you do that, you get that B is about 116.8 degrees. So again, on your actual work, I would just start out with this line and then that line to get that answer. And then the rest of this problem is now you're using the law of sines. So If we use A, looks like a smaller number. I don't know, it might be easier to solve for that one first. Again, it doesn't really matter which one you solve for first, A or C, but we're going to do the sine of A over A equals the sine of B over B. Plug in sine of A over 8 equals the sine of 116.8 over 19. To solve this for A, we need to get rid of the 8. We need to get rid of the sine. So instead of dividing by 8, we'll multiply. Instead of taking the sine, we'll do the sine inverse. So then A is the sine inverse of 8 times the sine of 116.8 degrees over 19. Type into the calculator, bleep, blop, bloop, 22.08 degrees. And then you could find C using the law of sines, but once you know two angles, right, you know all three angles have to add up to 180. So the easiest way to find out what angle C is would be to subtract the other two from 180 and see what's left over for the old angle C. So angle C is 180 minus my other two angles, which means angle C easy be 41.12 degrees. And if you spot check your work, you see that the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side. And the medium angle is opposite the medium side. All is right with the world. And you can go home to your mama, papa, or guardian and say, Mama, papa, look, I can solve missing angles of a triangle when I'm given three sides. Mama, papa, are you proud? And they'll go, yes, son or daughter, so proud, so proud. And won't that feel nice? It'll be nice, right? Yeah. If you go home and say, Mama, papa, I got, an A on my English paper, they go, English, that's not even a real subject? Doesn't everyone get an A in that? No, I'm just kidding. Don't tell an English teacher I said that. This building's full of English teachers. Yeah, it's, what is it? 1, 2, 3, 4, 5. There's 5 English teachers in this building and only 1 math teacher. So don't tell them I said that. Mr. Bear.
Just start streaming.
They're coming. Beat me up over lunch. Talk bad about English again. Do it. Do it.
I still have Mr. Bear's book from last.
Oh, you should return that to him.
Yeah. I was forgetting.
I set a reminder on the old phone. Set an alarm for 4:30. I tell you that works because it keeps going off for 2 weeks and I kept forgetting. Somebody returned a book and I didn't know whose book it was. And I had to go, hey, you don't care. All right, questions about this?
Billy, are you Mr. Bear besties?
I know, I don't think we're besties.
That's what he said too.
Yeah. Did you? Oh my God, Jacob.
Which means Mr. Bear too.
Good. This is good stuff. Good. All right. It is your turn for the fun. If it helps, you can draw an image of this, but you don't have to. Just know you need to solve for the largest angle first. And for this triangle with sides 6, A is 6, B is 8, and C is 12, which is the largest angle, A, B, or C?
C.
C. So solve for C first. I'll give you 3 minutes and then we'll go over it. Why is this formatted so bad? I don't like this. Fixed. That's better. I should probably use the text tool more than handwriting stuff. But all right, I'm gonna walk around. If you're not started, need help, stop me and I'll help you out. Oh yeah, that's a good explore the concept tip that I should mention. But we'll do this first. All right, Jacob,
Yeah,
what do I do first?
you write the equation,
Which equation?
cosine of angle C.
Yeah, so we should get cosine. I'm gonna go ahead and plug in my A, B, and C values to save us a line. So it'll be cosine of C equals 6 squared plus 8 squared minus 12 squared over 2 times 6 times 8. And then Hayden, how do I get rid of this cosine? Inverse. Type into the old calculator. And if it helps, you can simplify this before you type into the calculator. But you don't really have to. And in fact, what can make it easier to type this in, do you all know about if you hit math, go right to the number tab and then to the bottom, D will let you put in a fraction like a numerator and denominator. Yeah, okay, hold on. All right, stop share. Reshare. Whole screen. All right, so if you do math, go right to the number tab. And then you go all the way to the bottom, which if you hit up, it'll go all the way to the bottom. This, that'll let you put in a numerator or denominator. So if we do, hold on, is this, mine is in radians. Let's change that to degrees. Cosine inverse. Okay, now I'm going to do math. Go to number, down, fraction of 6 squared plus 8 squared minus 12 squared over 2 times 6 times 8. 117.2796, so about 117.28 degrees. Yeah, otherwise you have to make sure you put parentheses around the numerator slash parentheses around the entire denominator. You get a lot of parentheses. That I think is actually a newer feature. Yeah, and I think if you maybe grab the ones from like 16 to 30 over there, I don't know if all of those can do that. And if yours can't, I mean, you just got to use a whole bunch of parentheses. All right, Mariah, what do I do next now that I have C? You know what? Yes, find A next. The sine of A over A is equal to the sine of, what did you set A over A equal to? C over C. Yeah, use your givens. And so if we solve this, A is the sine inverse of A, 6, times the sine of C over C, so times the sine of 117.280 degrees over 12. Calculate. And if you calculate that, you should get about 26.38 degrees. And then Anna, how would I get angle B? That's exactly right. 180 minus 117 minus 26 equals, it'd be 36.34 degrees. And if you double check your work, you'll see that the largest angle is opposite the largest side. The smallest side is opposite the smallest angle. And the medium side is opposite the medium angle. And all is right with the world. Is your calculator in degree mode? First thing. Yeah, let me see. Okay, that is the end of today's, by the way. If you want to start packing up tomorrow, we'll do side angle side. To be honest, you can probably do it yourself. It is in degrees. That's good. So try cosine. You said so the only thing is difference is the little decimals a little bit off. Right, because you got 117.26, and we got 117.28. I think the only reason why is because you found it first and then cosine inverse. You use the rounded number, where if you type in the whole thing at once, it'll be more exact. But to be honest though, I think for most of the homework is like to the 10. So I don't think it'll matter if you type it over. And also, One trick you keep is. You know about this trick? That's it. That's right, you're asking about angle C, right? You're asking about angle C, right?
Yeah.
Okay, just make, yeah, you're on the right track. All right, so we'll finish 6.2 tomorrow. Homework's, no homework due tomorrow. Homework's due Monday. Have a good day, everybody.